Good morning, this is take 2 of the February 2nd lesson. Try it again. See if I can get a recording for you guys. All right, so we have significant figures in measurement. So a couple of the key ideas is that if we have significant figures, significant, that word means meaningful. So significant figures are all the meaningful numbers. And the third thing is that's important is that that is in a measurement. So significant figures are the meaningful numbers in a measurement. How do we normally define sig figs? We normally define them as all the known digits, so all the known digits plus one estimated digit. Okay, so all the known digits plus one estimated digit. In other words, all the certain digits plus one uncertain digit. That's the language we will usually use around it, is all the certain digits plus one uncertain digit. So let's take a look at a ruler like we had yesterday. And the smallest division, or smallest marking on this ruler is 1 centimeter. And if you recall from yesterday, we can estimate one more position to the right than that. So that is in the ones position, so we can estimate to the 0.1 position. So what that means is that when we look at this pencil here, we're absolutely certain that it is 6 point something. So the 6 is our certain digit. But the 7, that's the one we're estimating. So that could be 7, or it could be 6.8, or it could be 6.6. That is our uncertain digit. Now remember, significant figures are all the certain digits plus the one and only uncertain digit. So in this case, we have one certain digit plus one uncertain digit, certain, and that will give us a total of 2 significant figures. In other words, there are 2 meaningful digits in this number. It would be meaningless to go any further. If we were to write 6.70, that 0 would be meaningless, because if the 7 is uncertain, we can't really go past that and say anything meaningful about the hundredths position or the thousandths position. And again, with 6.700, also we cannot go past it. So we have 2 significant figures. Another way of writing that, if we're a little bit lazy, is we can write 2 sig figs. That's how we usually say it if we want to be quick. And on a quiz or something, if I'm marking it and I want to tell you that you should have had 2 sig figs and maybe you had 3, I would write 2 SF. I get really lazy when I'm marking quizzes because they take a long time. At any rate, you'll notice that our measurement could have been 6.7 or 6.6 or 6.8, because that tenths position is uncertain. So if the tenths position is uncertain, we could say that our measurement is 6.7 plus or minus 0.01 centimeters. This bit here, this plus or minus, is called the uncertainty. And the uncertainty means that basically that's, whatever your uncertain digit is, it could be plus or minus however the amount. Now, actually writing the uncertainty in your measurement is a black diamond activity. And if you've forgotten what a black diamond is, that means it is enriched, which means that writing the uncertainty is optional. And if you write the uncertainty on a quiz or a test, you will get a bonus. However, should you choose not to write the uncertainty on a quiz or a test, you won't lose any actual marks. You can still get 100% without having written that. So on a quiz, you would get 1 mark for writing length of pencil. You would get 1 mark for writing 6.7 or 6.6 or 6.8. And you would get 1 mark for writing centimeters. And then the bonus would be if you wrote that uncertainty. Now, one thing to note is the uncertainty always comes before the unit. So the uncertainty always comes before the unit. So would it be okay for me to write 6.7 centimeters plus or minus 0.1? Well, the answer is no, because the uncertainty should have gone before the unit. Okay, so this would be wrong. The other thing to know about uncertainties is that all of our uncertain digits, okay, whether we wrote a 6 or whether we wrote a 7 or whether we wrote an 8, that uncertain digit is in the hundredths position. Okay, so where were we? We were at the uncertain digit is in the hundredths position, which means that it is in the 0 point. Oh, it's not in the hundredths position. What am I talking about? It is in the tenths position, which is the 0.1 position. Okay, so if our uncertain digit is in the tenths position, then our uncertainty must also be in the tenths position. So you can see we've got our uncertain digit is 0.1 and our uncertainty is 0.1. Okay, so there we go. All right, so that is ruler A. Ruler B has many more divisions. It has many smaller divisions. And this means that this ruler is going to be more precise. If we have a ruler that is more precise, it is because it has smaller divisions on it. Now let's just remind ourselves what it means to be precise. If something is precise, if a set of measurements are precise, it means they are all close to each other. So precise means a set of measurements is all close to each other. All right. So we're going to keep that in mind as we go through this, and we're going to find out why it is that having smaller divisions makes the ruler more precise. So if we look at our ruler this time, we have 6. Our next little line represents 6.1. The next one is 6.2. And so each little subdivision represents 0.1 centimeter. And if the smallest division is 0.1 centimeter, then we can estimate to the 0.01 centimeter position. So if we look at this, we are right on the 6 point. This is 5, this is 6, we're right on 6.7. So we would say that the length of the ruler is 6.7. So length of ruler equals 6.7. Now, if I was to just stop right there and write centimeters, I would not be correct because I'm not uncertain about that 7. I'm sure that this measurement is not 6.6. I'm sure that it is not 6.8. I know that it is 6.7. So I have the 6, which is certain, the 7, which is certain, and we always need that one extra digit, which is uncertain. And because it is right on the line, we are going to add a 0. So there we are. And that 0, that is going to be our uncertain digit. So in terms of significant figures, if we count them up, we will be counting all the certain digits. Well, there are 2 certain digits. So we have 2 certain, plus we have, of course, only 1 uncertain digit, always only 1 uncertain, and that gives us a grand total of 3 sig figs, significant figures. That means this measurement has 3 meaningful digits in it. All right. Now, let's rewrite this measurement with the quote-unquote uncertainty in it. Remember, here is our uncertain digit. It is in the hundredths position, the 0.01 position. So if we write our number with the uncertainty, we would have 6.70 plus or minus 0. And in this case, it has to be 0.1, so that this uncertain digit matches with the uncertainty. Okay, and of course, we could not forget our units. All right. Now, I did forget my length of ruler, and I don't have a place to cram it in, but that is what we would have. Now, if our measurement is 6.70 plus or minus 0.01, that means this measurement could actually be as high as 6.71 centimeters. It could still be our 6.70 centimeters, or it could be as low as 6.69 centimeters. First thing I want to point out there is that even though we have a 6 in the tenths position and a 7th in the tenths position in those measurements, that's not an uncertain digit, because when we're changing from the 6.9 to the 70, we're not actually changing the tenths position. What we're doing is we're adding 0.01. We're actually changing the hundredths position. So hopefully that makes sense. If not, you can ask me about that later. Okay. Now, I promised to talk about why this ruler was more precise. Well, let's compare these measurements, which is ruler B, with the measurements that we had from ruler A. And the measurements that we had from ruler A could have been 6.7, 6.6, or 6.8. Okay, so ruler A could have been 6.6, 6.7, or 6.8 centimeters. And remember, precise means that the measurements are all close to each other. If something is very precise, the measurements are close to each other. The more precise, the closer they are. Let's take a look at ruler A and ruler B. Which one has measurements that are closer together? Hopefully, it's pretty obvious that ruler B, the measurements are closer together than in ruler A. Because in ruler B, they're only off by 0.01. There's an 0.01 difference in ruler B, and there's an 0.1 difference in ruler A. All right, so if we want to have a more precise measurement, we should use a measuring tool with smaller subdivisions. Okay, so that is point number 1, and we will write that at the top of the next page. Measuring devices with more subdivisions are more precise. So if being precise is something important, pick a measuring tool that has more subdivisions. Second thing I want you to note is that ruler B, remember ruler B was more precise, and each of those measurements has 3 sig figs. 3 sig figs. Okay, 6.69, 6.70, 6.71, those are all 3 significant figures. Whereas in ruler 2, we only have 2 sig figs. So the other thing that we can note about measurements and precision is that the more significant figures we have, the more precise the measurement is. So the more sig figs we have in a measurement, the more precise the measurement. Okay, and I think that that is where we're going to leave it for a lesson, part 1 of this lesson. Dear God, I hope this worked, and I will record lesson 2, part 2, a little bit later.